Rare earth elements and their applications. Rare earth elements are a combination of 17 chemical elements in the periodic table, see figure. This group is composed of yttrium and 15 lanthanide elements, lanthanum, cerium, praseodymium, neodymium, pronthium, samarium, europium, gadolinium, terbium, dysprosium, holmium, erbium, thulium, ytterbium, and lutetium. Scandium exists in most rare earth element deposits and is sometimes classified as a rare earth element. The International Union of Pure and Applied Chemistry includes scandium in its definition of rare earth elements. Rare earth elements are all metals, and this group is commonly referred to as rare earth metals. These metals have many similar properties, which often lead to their simultaneous discovery in geological deposits. They are also known as rare earth oxides because many of them are usually sold in the form of oxide compounds. Rare earth metals and their alloys are used in many devices that people use every day, such as computer memory, DVD, rechargeable batteries, mobile phones, catalytic converters, magnets, fluorescent lamps, etc. In the past 20 years, there has been a surge in demand for many items that require rare earth metals. 20 years ago, few people owned mobile phones, but today more than 5 billion people own mobile devices. The growth rate of the use of rare earth elements in computers is almost as fast as that of mobile phones. Many rechargeable batteries are made from rare earth compounds. The demand for batteries is driven by the demand for portable electronic devices such as mobile phones, readers, portable computers, and cameras. Each electric vehicle and hybrid electric vehicle's battery contains several pounds of rare earth compounds. With concerns about energy independence, climate change, and other issues driving sales of electric and hybrid vehicles, the demand for rare earth compound batteries will rise at a faster pace. Rare earths are used as catalysts, phosphors, and polishing compounds. These are used for air pollution control, lighting screens on electronic devices, and polishing of optical quality glass. It is expected that the demand for all these products will continue to grow. Among the most important uses of rare earth elements, other substances can replace them. However, these alternatives typically have poor effectiveness and lower costs. From the 1950s to the early 21st century, cerium oxide was a very popular grinding and polishing agent. It is both cheap and very effective. The recent price increase has almost eliminated the use of cerium oxide in rock rolling and grinding art. Other types of polishing agents, such as alumina and titanium oxide, are now also used to replace it. Rare earth elements play a crucial role in our national defense. The military uses night vision goggles, precision-guided weapons, communication equipment, GPS equipment, batteries, and other defense electronic devices. These have brought enormous advantages to the U.S. military. Rare earth metals are a key component of the very hard alloys used in the manufacturing of armored vehicles and shells, which can break during impact. Substitutes of rare earth elements can be used in certain defense applications. However, these alternatives are often not as effective, which weakens military advantages. The following table summarizes several uses of rare earth elements. Rare earth elements are not as rare as their names imply. Thallium and lutetium are the two least abundant rare earth elements, but their average crustal abundance is nearly 200 times that of gold in the crust. However, these metals are difficult to extract because it is unusual to find them in concentrations high enough for economic extraction. The most abundant rare earth elements are cerium, yttrium, lanthanum, and neodymium. Their average crustal abundance is similar to commonly used industrial metals such as chromium, nickel, zinc, molybdenum, tin, tungsten, and lead. Similarly, they rarely exist in extractable concentrations. History of rare earth production and trade. Before 1965. Before 1965, there was relatively little demand for rare earth elements. At that time, most of the world's placer mines came from placers in India and Brazil. In the 1950s, South Africa became a major producer of rare earth-bearing monazite deposits. At that time, the Shanka mine in California was producing a small amount of rare earth oxides in the Precambrian carbonate rocks. Color TV ignites demand. In the mid-1960s, with the first batch of color televisions entering the market, demand for rare earth elements exploded for the first time. Europium is the basic material for producing color images. The Yamaguchi mine began producing europium from fluorocarbon cerium ore containing approximately 0.1% europium. This effort has made Yamaguchi mine the world's largest producer of rare earths and made the United States a leading producer. China enters the market. China began producing a large amount of rare earth oxides in the early 1980s and became the world's leading producer of rare earth oxides in the early 1990s. In the 1990s and early 21st century, China steadily strengthened its control over the world rare earth oxide market. They sold rare earths at such low prices that Yamaguchi mine could not compete with many other mines around the world and ceased operations. Defense and consumer electronics demand. At the same time, with the rare earth metals being designed into various national defense, aviation, industrial, and consumer electronics products, the world demand has surged. China has taken advantage of its dominant position to restrict exports and allow rare earth oxide prices to rise to historical levels. China is the largest consumer of rare earths. China is not only the world's largest producer of rare earth materials, but also a major consumer country. They mainly use rare earths when manufacturing electronic products for domestic and export markets. Japan and the United States are the second and third largest consumers of rare earth materials. China's reluctance to sell rare earths may be to defend its value-added manufacturing industry. The pinnacle of China's production advantages. China's dominance may peak in 2010, when it controlled about 95% of global rare earth production, and the prices of many rare earth oxides increased by over 500% in just a few years. This is an awakening for rare earth consumers and miners around the world. Mining companies in the United States, Australia, Canada, and other countries have begun to reassess old rare earth prospects and explore new ones. The high prices have also led manufacturers to do three things. 1. Seek ways to reduce the amount of rare earth elements required to produce each product. 2. Finding materials to replace rare earth elements. And 3. Develop alternative products that do not require rare earth elements. This effort has led to a decrease in the number of rare earth materials used in certain types of magnets and a shift from rare earth lighting products to light-emitting diode technology. In the United States, the average consumption of rare earths per unit of manufactured goods has decreased, but there has been an increase in demand for more products made using rare earth elements. The result is an increase in consumption. China's purchase of overseas resources. Chinese companies have been purchasing rare earth resources in other countries. In 2009, China Non-Ferrous Metals Mining Company purchased a majority stake in Australian company Lynas, which is one of the companies with the highest production of rare earth elements outside of China. They also purchased the Baruba mine in Zambia. Rare earth production outside of China. Mines in Australia began producing rare earth oxides in 2011. In 2012 and 2013, their production accounted for approximately 2% to 3% of world production. In 2012, Yamaguchi mine resumed production, and the United States produced about 4% of the world's rare earth elements in 2013. Production in Brazil, Malaysia, Russia, Thailand, and Vietnam continues or increases. The new mineral resource assessment conducted by the United States Geological Survey has identified important resources outside of China. Although China leads the world in rare earth production, they only control about 36% of the world's reserves. This provides an opportunity for other countries to become important producers, as China's rare earth material sales prices are not lower than production costs. Rare earths are relatively abundant in the Earth's crust, but their recoverable concentrations are lower than most other minerals. The resources in the United States and the world mainly include based and monazite. Base deposits in China and the United States account for the largest proportion of the world's rare earth economic resources, while monazite deposits in Australia, Brazil, China, India, Malaysia, South Africa, Sri Lanka, Thailand, and the United States constitute the second largest market. Apatite, sodalite, diopside, chlorite, phosphorite, clay-containing rare earth, ion adsorption, secondary monazite, waste uranium solution and anorthosite constitute most of the remaining resources. Compared to expected demand, undiscovered resources are considered very large. Extracted from the Mineral Commodity Abstract of the United States Geological Survey. It is expected that the global demand for automobiles, consumer electronics, energy-saving lighting, and catalysts will grow rapidly in the next decade. The demand for rare earth magnets is expected to increase, and the demand for rechargeable batteries will also increase. The new development of medical technology is expected to increase the use of surgical lasers, magnetic resonance imaging, and positron emission tomography scintillation detectors. Rare earth elements are widely used in all of these industries, so the demand for them should still be high.